Preparing for a MongoDB Solutions Architect interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does a solutions architect do at MongoDB? A strong solutions architect translates business requirements into a secure, scalable, operable design. At MongoDB, I would clarify workload shape, latency, availability, consistency, security, and cost targets before proposing an architecture. I would explain trade-offs clearly, validate them with a proof of concept, and leave implementation guidance the engineering team can execute. Success is measured by business outcomes, not by choosing the most sophisticated technology. While answering, focus on translating business requirements into architecture, balancing performance, availability, security, and cost, collaborating with sales and engineering, and proving recommendations through technical validation rather than simply describing product features. Question 2. Why would a customer choose MongoDB over a relational database? The strongest case for MongoDB is flexibility combined with scale. Documents map naturally to application objects, so teams can evolve schemas and release features without coordinating every table change. MongoDB also provides replication, horizontal scaling, rich queries, and transactions when needed. I would not present it as universally superior. Highly relational workloads with complex joins or mature SQL tooling may remain better served by a relational platform. The recommendation should follow workload characteristics. Make sure to cover flexible document modeling, rapid development, horizontal scalability, natural representation of hierarchical data, high availability, and the situations where relational databases remain preferable because of joins, rigid schemas, or established transactional requirements. Question 3. How would you model data in MongoDB? I start with the questions the application must answer, rather than converting existing tables mechanically. I embed data when it is bounded, read together, and updated within the same workflow. I reference data when relationships are large, shared, or independently managed. For example, order line items often belong inside an order, while customer profiles should remain separate. I then test document growth, query patterns, write frequency, and operational limits using realistic data volumes. In your answer, talk about modeling from access patterns, embedding versus referencing, document size, update frequency, cardinality, atomicity, duplication, and lifecycle requirements. Then explain how you would validate the design with representative queries. Question 4. When would you embed documents versus use references? Embedding is appropriate when related information is usually retrieved together and has a bounded size, such as an address inside a customer profile or items inside an order. References are better for unbounded collections, shared entities, or data updated independently, such as products referenced by many orders. I also consider duplication. Denormalizing a product name may improve reads, but it creates update responsibility. The decision should optimize dominant access patterns, not theoretical normalization. Be sure to mention bounded versus unbounded relationships, read locality, atomic updates, duplication tolerance, independent access, document growth, and the risk of creating oversized documents or expensive application side joins. Question 5. How do you identify and resolve a slow MongoDB query? I begin by reproducing the query and reviewing its explain plan, especially whether it performs an unexpected collection scan, in-memory sort, or excessive document examination. I compare examined and returned counts, then design an index aligned with equality, sort, and range predicates. I retest with production-like data and concurrency, because an index that helps a small dataset may fail at scale. Finally, I confirm improvement through monitoring rather than relying only on explain output. Focus on query shape, explain plans, collection scans, index selectivity, sort stages, returned documents, data volume, profiler evidence, and iterative testing. Also distinguish query problems from hardware, locking, or workload concurrency issues. Question 6. How would you design indexes for a MongoDB workload? I design indexes around the highest value query shapes. For a query filtering by tenant and status, then sorting by creation time, I might lead with tenant and status followed by the sort field, subject to selectivity and workload testing. I avoid indexing every field because indexes consume memory and slow writes. I also check whether multi-key or low cardinality fields change behavior. After deployment, I monitor usage, latency, storage, and write impact, then remove ineffective indexes. In your answer, cover query-driven index design, compound index ordering, selectivity, sort support, write overhead, index size, covered queries, multi-key behavior, and the need to verify actual usage with explain plans and production monitoring. Question 7. What is a MongoDB replica set, and how does it provide high availability? A replica set maintains multiple copies of data, with one primary accepting writes and secondary members replicating the operation log. If the primary fails, eligible members hold an election and a new primary takes over, usually with brief interruption. Applications should use the MongoDB driver's topology awareness and retrievable operations appropriately. I would also discuss write concern and read preference, because availability, durability, and read locality depend on those choices. Make sure to cover primary and secondary members, elections, replication through the oplog, read preferences, write concerns, failover behavior, voting members, and application connection handling during topology changes. Question 8. How would you explain read concern and write concern to a customer? Write concern describes how much confirmation a write requires, while read concern describes which data state a read is allowed to observe. For critical financial events, I may recommend majority acknowledgement and a sufficiently strong read concern to reduce rollback or stale read risk. For low-value telemetry, weaker settings can reduce latency. I would not prescribe one configuration globally. I would map each workload's consistency, durability, availability, and performance requirements to explicit settings. While answering, distinguish acknowledgement from durability and visibility, explain common write and read concern choices, discuss latency trade-offs, and connect settings to business requirements such as payments, analytics, or user-facing availability. Question 9. When would you use MongoDB transactions? MongoDB already provides atomicity for updates to one document, so I first ask whether the data can be modeled around that boundary. I use multi-document transactions when a genuine business invariant spans documents, such as transferring value between accounts. I keep transactions short, avoid external calls inside them, and handle transient errors with driver-supported retries. If transactions dominate the workload, I revisit the schema, because excessive cross-document coordination can become a scalability constraint. Be sure to mention single-document atomicity, multi-document transaction use cases, latency and contention costs, transaction duration, retry handling, schema redesign, and why transactions should not compensate for an unsuitable data model. Question 10. What is sharding, and how would you choose a shard key? Sharding distributes documents and workload across multiple servers, allowing horizontal scale beyond one replica set. I choose a key with high cardinality, good write distribution, and alignment with frequent queries. A monotonically increasing identifier can create a hot shard, while a purely random key may scatter every query. For a multi-tenant system, tenant identity might work if tenants are balanced, but large tenants may require a compound or refined strategy. I validate distribution under realistic traffic. Focus on distributing data and traffic, cardinality, frequency, monotonicity, query targeting, hotspot avoidance, tenant isolation, resharding implications, and the trade-off between even distribution and efficient routing. Question 11. How would you prevent hotspots in a sharded MongoDB cluster? I distinguish data skew from traffic skew, because evenly sized chunks do not guarantee evenly distributed requests. I would inspect the shard key's cardinality and monotonicity, then consider hashing, a compound key, or a refined key that combines tenant and entity attributes. I would also review query targeting so the application does not broadcast requests unnecessarily. Testing should include the busiest tenants and peak write patterns. Average production traffic can hide severe hotspot behavior. In your answer, cover monotonically increasing keys, uneven tenant sizes, hashed or compound strategies, workload distribution, targeted versus scatter-gather queries, chunk balancing, and monitoring both data skew and request skew. Question 12. How would you migrate an existing relational application to MongoDB? I would avoid a direct table-to-collection conversion. First, I would inventory transactions, queries, data ownership, and operational constraints, then design documents around the target application's access patterns. I would migrate a representative slice, validate counts and business invariants, benchmark critical queries, and test failure recovery. For cutover, options include dual writes, change data capture, or a staged read switch. I would define rollback and reconciliation procedures before moving production traffic. Make sure to cover discovery, workload and schema analysis, target document design, dual writes or change data capture, validation, phased cutover, rollback, reconciliation, application changes, and measurable performance and correctness criteria. Question 13. What security controls would you recommend for MongoDB Atlas? I would build defense in depth. That includes strong authentication, role-based least privilege, private network connectivity, IP or security group controls, TLS, encryption at rest, and customer-managed keys where regulatory requirements justify them. I would enable auditing for sensitive environments, store credentials in a secrets manager, and separate application, operational, and security responsibilities. I would also review backup access and recovery procedures, because protected production data can still be exposed through poorly governed backups. Focus on least privilege access, authentication, network controls, encryption in transit and at rest, customer-managed keys, auditing, secrets management, private connectivity, backups, and separation of administrative responsibilities. Question 14. How would you design a multi-region MongoDB architecture? I begin with recovery point, recovery time, latency, and sovereignty requirements. I might distribute replica set members across 3 regions to preserve election safety, use nearest region reads where stale data is acceptable, and place write responsibility according to the business workflow. If active writes are required, I would examine conflict and ownership implications rather than assuming geography solves them. I would test regional failure, DNS or driver routing, elections, and application behavior before declaring the design resilient. In your answer, discuss regional failure objectives, member placement, read locality, write locality, election behavior, latency, majority durability, application routing, data sovereignty, and the distinction between disaster recovery and active processing. Question 15. How would you approach backup and disaster recovery for MongoDB? I translate business recovery objectives into technical controls. I would configure continuous or frequent backups for the required point-in-time recovery window, retain copies in an appropriate independent region, and protect them with encryption and access controls. Then I would regularly restore into an isolated environment, validate data and indexes, and measure actual recovery time. A disaster plan also includes application configuration, secrets, DNS, dependencies, ownership, and a tested runbook. Backups are not sufficient unless restoration works. Be sure to mention RPO and RTO, backup frequency, point-in-time recovery, cross-region copies, encryption, restoration testing, application dependencies, operational runbooks, and evidence that recovery objectives work under realistic failure scenarios. Question 16. How would you use MongoDB aggregation pipelines effectively? Aggregation pipelines let me process documents close to the data using stages such as match, project, group, lookup, and sort. I push selective filtering early, project only needed fields, and confirm indexes support the initial match and sort where practical. I watch memory, cardinality, and lookup cost, especially on large datasets. For repeated or heavy analytics, I may materialize results or use a separate analytical path rather than allowing reporting queries to disrupt transactional traffic. Focus on pipeline stages, filtering and projection early, index usage, grouping costs, joins through lookup, memory and spill behavior, explain plans, materialization options, and choosing between operational queries and dedicated analytical workloads. Question 17. What are change streams, and when would you recommend them? Change streams expose database changes as consumable events, allowing applications to react without polling collections. I would use them for notifications, cache invalidation, search synchronization, or integration workflows where near real-time propagation matters. Consumers must persist resume tokens, handle reconnects, make processing idempotent, and account for delivery and ordering semantics. I would also filter events early and define what happens when downstream systems are unavailable, because an event pipeline needs operational guarantees beyond simply opening a stream. While answering, explain event-driven data capture, replica set requirements, resume tokens, ordering scope, filtering, consumer reliability, ID impotency, and suitable use cases such as notifications, caches, search indexes, and integration workflows. Question 18. How would you troubleshoot a MongoDB performance problem in production? I first define the symptom precisely, elevated latency, errors, replication lag, or throughput loss, and identify when it began. I correlate database metrics with deployments, traffic, query shapes, resource saturation, and replication health. I use profiling and explain plans carefully, avoiding disruptive experiments during an incident. Immediate actions might include throttling a workload or adding capacity, followed by root cause correction. I document evidence, validate the fix, and add monitoring to prevent recurrence. Make sure to cover symptom definition, recent changes, metrics, query profiling, CPU, memory, disk latency, connections, locks, replication lag, workload isolation, safe mitigation, and communicating findings without making untested changes. Question 19. How would you demonstrate MongoDB's value in a customer proof of concept? I would agree on measurable success criteria before building anything. P95 latency, throughput, availability, migration effort, developer productivity, and cost boundaries. The proof of concept should use realistic document sizes, indexes, concurrency, failure tests, and security controls rather than a synthetic happy path. I would compare results with the customer's baseline, explain trade-offs, and document production gaps. A credible POC proves repeatability and operational readiness, not just that one query executes successfully. In your answer, cover success criteria, representative data and traffic, baseline comparison, architecture assumptions, functional validation, performance testing, operational checks, security requirements, total cost, and a documented path from prototype to production. Question 20. How would you handle a customer who insists on recreating a relational schema in MongoDB? I would first understand why the customer prefers that design, regulatory controls, team skills, migration risk, or complex relationships. I would not dismiss those concerns. Then I would map the important access patterns and show where document modeling could reduce joins and improve ownership, while acknowledging cases where references or another database remain appropriate. A small benchmark using their data is more persuasive than a generic argument. My goal is the best architecture, not winning a technology debate. Be sure to mention listening first, understanding the reason, identifying access patterns, demonstrating document-oriented alternatives, acknowledging valid relational use cases, using evidence from a prototype, and preserving trust rather than forcing a migration. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.